Lesson 7.3, absolute value equations. We're going to consider case 1, case 2. So case 1 is where we keep the equation exactly how it is when we remove the absolute brackets. Case 2 is where we remove the brackets but we put negative of those values in its place, because whenever we have an absolute, it could have been a positive value going in there or a negative value going in there. So we have to account for both of those situations in order to get all the possible solutions to these equations. So example number 1, we're going to solve 6 minus x equals 2 graphically and algebraically. So graphically is where you put that into your graphing calculator. So what you would do is you would put the left side into y1. So you'd go math to the right to number 1, absolutes. You're going to put 6 minus x. And then you can put 2 into y2. The left side, it goes into y1, the right side goes into y2. You can graph it, and the intersection between these two graphs, the blue and the red, are your solutions. So if I go second trace, number 5, intersect, I can get as close to the intersection and press enter. So I should see an intersection at, the coordinates are 4, 2. You only look at the x coordinate for the answer. So the answer is 4. So I would write that the answer, if I were to graph it, we have one equation. One equation was at 2. And the blue one, when I graphed it, was at so it looks something like this. Okay, so I need to find both intersections. So one intersection was at x equals 4, and then I have to find the second intersection by doing second trace number 5 again, going as close as possible to this intersection point and pressing enter 3 times. So you should find that the intersection is, let me try it again, second trace number 5 is at 8. So x equals 8 is the second intersection point. And so that would be how you do it graphically. So that would be one way of doing this. And then algebraically is where you remove the brackets. You do case 1. Case 1 is where you remove the brackets and don't do anything. Solve for x. You would have to go 6 minus 2 equals x. So I switch these spots over by changing their signs. So the 2 became negative 2, the x, negative x became positive x. So that's going to be 4 equals x. So that's one solution. But you only get one of the two solutions if you do case 1. So that's why you have to do case 2. Case 2 is where you make the negative, meaning the opposite signs of what's in the absolute. So you remove the absolute brackets, but you change the actual signs. So it became negative 6 instead of positive 6 and positive x instead of negative x. And so then we're going to add 6 to both sides to get that x equals 8. So that's our second solution. So by doing these two different methods, we have checked that our answer is correct. There is 2 solutions. Example number 2, it says that a computerized process controls the amount of fish that is packaged. So we know that if we have a certain mass, and if we subtract 170, we're going to get we're going to get 6, meaning the absolute of the mass minus 170 is going to give us positive or negative 6. So this is how we would write that equation, because the absolute of this, case 1, if we were to solve, would look like m minus 170 equals 6. So what we're going to do is add 170 to both sides. So the maximum mass we can get is 170 grams, 176 grams if we add them together. Case 2 is where within the absolutes we change the signs. We're going to go negative m plus 170 equals positive 6. So negative m equals negative 170 plus 6. We're going to move that 170 to the other side to change the sign. And then negative m equals negative 164 grams. And then we would divide both sides by negative 1, meaning the mass is 164 grams. So this is the minimum mass that we can have, and this is the maximum mass that we can have. So that's how we find out our answers. So that's algebraically done by doing case 1, case 2. Okay, our next example, we're going to do this one algebraically. So case 1, we remove the absolutes and don't change anything else. Case 2 is where we remove the absolutes, but we make the signs inside the absolute the opposite, meaning negative in this case. Negative x, negative 5 instead of x plus 5. Everything else stays the same. Then in both cases, we have to solve for x, meaning you need to bring the x's to one side. So we're going to start by, in this case, subtracting x to both sides. That means that 5 is equal to 4x minus x is 3x minus 1. Then we're going to add 1 to both sides. That means 6 is equal to 3x. If we divide by 3, we get that x equals positive 2. So we're going to see if that's an answer. We always need to check our answers. Here we're going to add x to both sides. Again, do the opposite sign. Negative 5 equals 5x minus 1. And then we're going to add 1 to get x by itself. 5x equals negative 4. And then we have to divide by 5. X equals negative 4 over 5. So these are your two answers, but what we're going to do is we're going to check this answer graphically. So we're going to start by putting the left side, which is math, number 1, we're going to put 4x plus 5 into our absolute value brackets, and then we're going to, oh, actually it should be another one. Should be math number 1, x plus 5. And then on the other side of the equation, the right side, which is y2, we're going to put 4x minus 1. Graph it. And as you can see, there's only one intersection, which means that there should only be one answer. So graphically, you will see the real answer. So we're going to go second trace, number 5. We're going to move as close to the intersection as we can. Press enter 3 times. Enter, enter, enter. So the intersection occurs at x equals 2. That's the only answer, because if you look anywhere else, there is no other intersection. So this is our only real answer. So I'm going to check mark this, and I'm going to cross this one off because it doesn't actually work. That one is not a solution, which is why you need to check your answers. Example number 4. Algebraically, if we go 4x minus 5 in absolutes, we're going to bring the 9 over first by subtracting 9. Now this does not work. There's actually no solution. The reason I knew that is because an absolute is not allowed to equal a negative value, so there is no solution. So absolutes cannot be negative. So if the entire absolute is negative 7, that doesn't exist, so there is no solution here. If we were to actually try to continue to solve, it does not exist. Example number 5, we're going to do case 1 is x squared minus 3x equals 2. We're going to bring the 2 to the other side by subtracting 2. And then we can actually try to factor this if it's possible. So this one's they're not really nice numbers, so you can do the quadratic equation or you can graph this to solve this. So I would graph the x squared minus 3x minus 2 and find the x-intercepts. So this is a graphical solution that I'm doing here. I'm going x squared minus 3x minus 2, graph it. Find the x-intercepts by going second trace number 2, which is 0s. Go to the left side of that x-intercept, the right side of that x-intercept, and then your first 0 is negative 0.56. And the second one, second trace, number 2, go to the left side of that x-intercept, that's the left bound. Then the right bound is here. Enter, enter. You get 3.56. So those are your two possible x-intercept. Now we're going to do case 2. So don't forget that you need to do case 1, case 2. This is going to be x squared, negative x squared, because you have to change the sign, positive 3x equals 2. So only what's in the absolute changes signs. We're going to bring everything to the right side to make it positive. So x squared minus 3x plus 2. This is not actually nicely factorable. We can find two numbers that multiply to 2 and add up to negative 3. So that would be x equals 2 and x equals 1. So we're going to check this in the graphical sense to see how many solutions there are, to see if they're all solutions. So this is where I put math number 1. We go to x squared minus 3x, and in the right side we put 2. We're going to graph this, and if you look closely, there's actually 4 intersections. There's 1, 2, 3, 4 points that intersect, which means that all of these are solutions. So I'm going to check mark all these because there are actually 4 different x-intercepts, or intersection points. So there's 4 possible solutions here. So I check mark all of them because they are all real solutions. Case number 6, case 1. Remove the absolutes, don't change anything else. And then we're going to move everything to the right side. 0 equals x squared, negative 8x minus x, and then plus 15 plus 5. So that's going to be 0 equals x squared minus 9x plus 20. Well, this is nicely factorable. Two numbers that multiply to 20 and add up to negative 9 would be x minus 5 and x minus 4. So that means that x could equal 5 or 4. Let's do the negative version of it. So that will be case 2. Negative x plus 5, that's the opposite signs of what's in the absolutes, equals the same thing on the right. So we're going to have 0 equals x squared. Then we're going to have minus 8x plus x plus 15 minus 5. So that will be minus 7x and then plus 10. Again, nicely factorable. Two numbers that multiply to 10 would be x minus 5 and adds up to negative 7, x minus 2. So x could equal 5 and x could equal 2. So you could always check by plugging it all in to see if left side equals right side, or you can also do this graphically. So the graphical method, again, finding the intersections. So I can put the left side into y1. So in absolutes, go math number 1, x minus 5, and on the right side we have x squared minus 8x plus 15. Graph it. There seems to be some solutions here. Now we're going to check. It seems like there's only 2 solutions. So we're going to go second trace number 5. Go as close to the intersection as you can. second trace. So the intersection, one of them is at 2, so we're going to check mark that 2 is a solution. And then second trace, number 5 again. The other solution seems to be at 5. So the 5s are correct, but the 4 doesn't exist. If we were to check that, that one does not give us a correct solution, so we can cross off the x equals 4. Now with this one, if you want to do these, you would have to do, there's multiple different things. I would actually do this one graphically. So I would just go, this is y1, this is y2, and find the intersection. So that would be the fastest way to do those kind of ones. But that one's a little bit above what the curriculum says. So we're going to